Hey everyone, John here, senior software engineer with 10 years of experience helping you land your first or next programming role with Latterly.io, an open source educational and social community. You can sign up for free, GitHub down at the bottom, 24/7 support with an AI chat, and you can unlock additional features starting at $1 a month. There's also the Discord under the community tab. So that's who I am, and today I am using the Latterly leetcode kata. Let's see if I have this. I guess I don't have it open in any of my tabs. So I'll go over to the blog. It's blog article number 3. The Latterly leetcode kata, which is a coding round preparatory tool. And it's also a really great way to warm up your brain and get ready for an interview. So I have an interview in like 20 minutes. And I wanted to touch on a few aspects of the way that I use this tool to get ready for an interview. So everything is review here. At this time, we are not using it as a learning tool. So the kata can be used in 2 ways. It can be used as a learning tool or as a review tool. The whole point of the pre-interview kata is to minimize stress, to improve confidence, and bring technical concepts to top of mind. So if I were to use it to try to learn a new concept right now, I would be increasing stress. That's not the point. The point is to repeat problems I've done 100 times or more, to get myself into my comfort zone, basically. Okay, so that's one thing that we're doing. And so you start right at the top with two-sum, really easy problem. That's one thing that I'm doing. Another thing that I'm doing is I'm going to scale this to the time available, and I'm not going to try to force myself to do all of the problems. Okay, that's key. If I force myself to do all of the problems, that would be another source of introducing stress. That defeats the point. So I would ideally like to do at least 2. So I'd ideally like to do this kata for at least 5 minutes. After you've done the kata several times, you can do 2-sum and 3-sum in 5 minutes. But yeah, really, like, I try to allocate 30 minutes to an hour, anywhere in that range, depending on the schedule availability that I have. If it's a really flexible day, I have no other calls going on, I'll do a whole hour. If I have a bunch of calls going on, and today I have multiple, so I might walk it down to 30 minutes. In this case, I think I'm going to do like 15 minutes. So those are some of the ways to use the kata. Here's some other things that I'm doing. One, before I come to the kata, I've slept, I've eaten, I have my coffee. These are all things that I'm doing to get ready for the interview. I have gotten sunlight in my eyes. I walked outside. It's easy to underrate these things, but I think they're actually all really important for cognitive activation and to drop that stress and help you get into a focus mode, which is really what the kata is great at. One last thing that I also wearing the blazer. I mean, appearance matters. I probably should have cleaned up some of my beard a bit more, but we have some sort of a quality bar in place. It's another of the check we're doing. And the last thing that I do is I review the company. So these should all be review. And I review the job posting. So in this case, we're looking at a senior full stack developer at Anchor Watch. This is not the first time I'm looking at this. I wouldn't have accepted the interview without looking at the company and without looking at the role. But I also want it to be top of mind in parallel to the kata. When I get on that call, I want to know who I'm talking to. So just take 5 minutes. You don't need to do a research project. Just take 5 minutes and remember, okay, this is the position. This is why I care about it. These are the techniques they're looking for. These are the talking points that I'll bring up. Zod, TRPC, right? Tailwind, great stuff. Bitcoin. So here I might refer to, like, I wrote price forecasting on Bitcoin. I've been dealing with Bitcoin for more than 10 years, that sort of thing. Okay, so we refreshed our mind about this, and now we'll do the kata. And then the last note that I'll make is I am not doing this kata up to the minute of the interview beginning. I'm going to allow myself at least 5 minutes, ideally, 10 to 15 minutes. You don't want it to be too much of a decompression break, a relaxation time, where you literally you're just like quiet, maybe sitting in your chair. You can put on music if you want, or just silence, either way. that might vary per person. I haven't done enough testing on myself to know whether music helps or not. Usually I go for silence. Occasionally I'll play a song just because I'm in the mood, but I don't actually know if it helps. And that decompression time, I think, is also very important. Right, so you don't want to have too long of a break or your short-term memory will start to forget the details you just refreshed. So at least 5, and then for me, 10 to 15 feels like the sweet spot. I don't know, maybe tune that based on your person. Okay, so that is a lot of the context around using a kata for just before going into your interview. And I know the video's title is interview prep, so maybe I should have worded that better. This is literally before walking into an interview. Or virtually turning on Zoom. And I don't think that I've shared all that context in one place. So I wanted to go through that. And now that we've done that, let's do a couple of these problems. I think we still have time. We'll just do 2 of them. Yeah, we'll just do 2 sum and 3 sum. And then I'll take my little break. Even longest substring without repeating character, it wouldn't be tough. But the decompression time, I just don't want to sacrifice it. So 2 problems is good enough. One moment. Let me make sure my kids are behaving. Why are you both in here? Go to the play area, please. One kid in the bathroom at a time. They were throwing glow light balls in the bathroom. Okay. Quick question from the audience. If the recruiter says, we'll call you in 1 to 2 days, but they don't, then you follow up, right? I would allow 3 business days. So, if they said 1 or 2 days and they told you that on a Thursday, don't text them on a Saturday, right? So let's say it's a Thursday. Isn't today Thursday? Yeah. Okay. So we don't even have to hypothesize, or we don't even have to imagine it's Thursday because it actually is. If a recruiter told me today, hey, we'll give you follow up on the call in 1 or 2 days, I would follow up if needed next Tuesday. Does that make sense? That would be my advice. And this is like standard advice in the laterally networking scripts is the 3 strikes rule for following up. And so basically you want to separate the follow-ups by a calendar week with a minimum of 3 business days. Cool. 2sum says, given a 1-indexed array of integers, we'll call it numbers, it's already been sorted in non-decreasing order. Why do we say non-decreasing rather than increasing? Because I might have a run of identical numbers, 222, 333. It's not increasing, but it's non-decreasing. So let's find 2 numbers such they add up to a target number. Let those 2 numbers be called the index 1 of numbers and the index 2 of numbers. Again, it's 1 indexed, so the index 1 and 2s will be distinct between the allowable range. And we will return the indices as a list that will always have length 2. Tests are generated, so there's always exactly 1 solution. We don't need to worry about multiple solutions. We don't need to worry about an empty set of solutions. So, intuition, given that it's sorted, we can use pointers set to the outer bounds, which will scan every element in the worst case. So time complexity is O of n. And space complexity is constant. Ari, this is great. Look into the prep process. This is a great look into the prep process. Thank you, Ari. Thank you for being here. If you're on TikTok, by the way, I would appreciate some likes. Thank you for the follow, Vessel and Frickin. Frickin Dude. Thank you for the follow, Frickin Dude. Love the username. Yeah, so I'd appreciate, tap the screen, give it some likes. That will help the algorithm send the video around. And want to call out, if you're having trouble seeing the screen on TikTok, you can visit YouTube or Twitch. The link is in my bio. You can join Ari and see the full screen. Okay, so we initialize left to 0. Right is the length of numbers. minus 1. And we will say while left is less than right. We do this to avoid effort duplication. Whenever you're adding two numbers 1 and 2 versus 2 and 1, the sum is the same. So it's unnecessary work. So whenever the pointers cross index, we can just exit because we'll end up with the duplicates that we're not supposed to have anyway. So the current sum is the left of numbers plus the right of numbers. And there are 3 comparison cases when you think about the target relative to that sum. The target could be above the current sum, below it, or you could have a match. Okay, so this is a bit of pseudocode. Let's clear it up. The current sum is above the target in this case. The current sum is below the target in this case. And it's not the left plus the right. It is going to be the left of numbers plus the right of numbers. In the match found case, we want to return the 1 index because I initialized left to 0. We'll need to add 1. And so with right. And what do we do if the current sum is too large? We want to decrease the current sum. So given that I have my pointers on the outer boundaries, right cannot go further to the right to grow the current sum. Remember, they're sorted. So if I want to grow the current sum, then I need to move left up. If I want to grow the current sum, I need to move left up. And that would be the case where the current sum is too small. That's when I want to grow it. In this case, I want to move right down to decrease the current sum. Cool. And that's 2 sum. I'm actually going to go ahead and wrap. I'll do the pseudocode on 3 sum. We'll do the structure of the problem and skip the implementation details for 3 sum. Okay. 3 sum, number 15. Given an integer array called nums, let's return all of the triplets. The triplets in this case are value sets. They are not index sets. So I have num sub I, num sub j, num sub k, where I, j, k are distinct. And then the triplet of these values add to 0. We said that the solution set must not contain duplicate triplets, but within example 1, we can see an output that includes 2 negative 1s. So the values within a triplet may be duplicate, but the triplet itself may not be duplicate. So we'll want to use a set and a tuple to deduplicate those triplets. In Python, your mileage may vary by language. In Python, the tuple is hashable, so it will be auto-deduplicated within a set. You wouldn't want to use a list in Python because it's not natively hashable. But in other languages, sometimes it is. Okay. So yeah, the difference between the 2 sum that we just did, here, you're always having a target across the 3 of 0. And also, you might have an empty set case in example 2. You might have a duplicate set case in example 1. Freaking dude, what is the runtime of the built-in sort in Python? N log n. It's n log n. So the intuition is, and I think maybe you're pointing at the answer, freaking dude. I love that username. Is that we totally should sort this. Let's sort nums, costs non-binding n log n. Then we can apply an outer wrapper to an inner 2 sum. This costs O in squared time complexity. Amir Dust, thank you for the likes. We can use pointers. So space complexity is O1, which is constant. So here we want to start by nums.sort, and then we want to say that the outer left is 0. We want to declare results, which is going to be a set. set up for auto deduplication of tuples. And then we'll have this while condition, while outer left is less than, we're just going to scan through all of the numbers. So while it's less than the length of numbers, we're going to find the complement. We're going to call toSum. We're going to fast forward duplicates. We'll eventually return results. Down here, we'll define toSum. And the left is going to be the outer left plus 1. And you'll have a while condition. While left is less than right. You will get cursum. 3 comparison cases. And then on match, add tuple to set and fast forward dupes. So this is what I mean by outlining the structure of the problem in pseudocode without doing the low-level implementation. So that is basically the pseudocode solution to 3Sum, the optimal one. And with that, I'm going to go ahead and wrap up, and I'm going to take, what'll it be now? Looks like bang on 10 minutes before joining my interview call. Wish me luck.